The latent frost effect. What's the latent frost effect? Not lederhosen. The latent frost effect is when hotter temperatures result in slower boiling time. Confused? So what's happening? Well, let's start with a hot surface. Now, if that hot surface has a temperature under 220 but over 120, we put a droplet of water on it, the water turns into vapor and forms vapor bubbles. These bubbles then rise out of the droplet and into the air, but if the temperature is over 220, the droplet seems to float on the hot surface, suspended on vapor. No. Yes, the vapor lifts the water droplet. So now for the nerds, if we plot temperature versus rate of heat transfer, then if the temperature increases, the rate of heat transfer also increases. That makes sense, right? The more heat we put into it, the faster the water vaporizes. But after about 220 degrees, this begins to change. In fact, if we take the many data points, we see the following graph. The boiling can be characterized by 3 different stages, A, B, and C. Well, that's just what I call it because I ran out of room on my whiteboard. The first stage is called nucleated boiling. The second stage is transition boiling. The third stage is film boiling. The first stage tends to have small bubbles that leave slowly. The second stage has exploding bubbles. And the third stage has the later frost effect. Yes, vapor floating a droplet. So what about the math? With nucleated boiling, yeah. Oh, good question. But a guy named Bromley realized that nucleated boiling did not apply to this effect. So he related heat convection to the laminar flow of the vapor under the droplet, with some assumption is 0. So that's cool, but can I make it happen? First, I got a thermocouple from the checkout lab. Then I got a stove, my stove. And yes, it is missing a dial and a handle for the oven. No, I did not break the dial, but I did break the handle. Sorry, I was excited getting cake out of the oven. So then I heated up a pan and started the experiments. Those are not tears, even though many tears were shed. Okay, here we go. So, what did I learn? I learned that it was harder than I thought to measure its effect as a function of temperature. Why? Well, probably the non-stick pans. What happens when I put the water on the pan is there's not a lot of surface contact with the pan, not what I was planning. Also, there were a lot of impurities from the other water left in the pan. What happens when there's impurities left in the pan from the hard water we use from a tap? Yes, spinning droplets of death. So I moved to glass. And while it seemed to work better at first, I learned that Pyrex does not like being heated over 200 degrees and having cool water dropped on it. Yeah, not really. Doesn't matter. Well, so you can stick your hand in molten metal, of course. Please see Mythbusters for this. Do not try at home. That's the later frost effect. Later frosting.